This is the question from the GATE 2020 set 1. Question is, air ideal gas enters a perfectly insulated compressor at a temperature of 310 Kelvin and the pressure ratio for the compressor is 6. Specific heat at constant pressure for the air is 105 joule per kg Kelvin and the ratio of specific heats at constant pressure and the constant volume is 1.4. Assume that the specific heats of the air are constant. If the isentropic efficiency of the compressor is 85%, the difference in the enthalpies of air between the exit and the inlet of compressor is. So first we will draw the schematic diagram of TS diagram for the compressor. These are the isobaric lines. So when we compress the process ideally, means we consider it a complete straight line vertical. So this is the ideal 1 and 2 and this is the irreversible 2 dash. So compression from 1 to 2. Then from the given data we will first find the temperature of all the points and then we will find the enthalpy difference. So first we write the given data. T1 as 310 Kelvin and RP is given as 6. So we have to first find the T2, then T2 dash, and efficiency for the compressor is given as 0.85. Now we know that for the ideal gas and reversible process, T2 by T1 is equal to Rp to the power gamma minus 1 over gamma. So we know the value of all those data, and from here we can calculate the T2. Calculate the value of T2 310 T1 Rp is 6 and gamma is 1.4, so 0.4 divided by 1.4. So when we calculate this T2 value, this will become 517.2382. Now coming to this 2 dash value, how we will find this 2 dash value? Here this isentropic efficiency will come into picture. Isentropic efficiency for the compressor is the ratio of the enthalpy difference for the ideal. Means we have to give less amount of work power input to the compressor for the isentropic process, and we have to give more power to the compressor for the irreversible process, and reverse will happen for the turbine, but here compressor, so we will write that accordingly. Means amount of energy input for the isentropic process is H2 minus H1 divided by H2 dash minus H1. So for here, air is considered as ideal gas. So for the ideal gas, enthalpy is the function of only absolute temperature. So and Cp for the air is considered as constant. So all Cp will cancel out and it will become only function of temperature. T2 minus T1 divided by T2 dash minus T1. So all data is given. Here from here we can easily find the value of this T2 dash. 500 minus 310 divided by T2 dash minus 310. So when we will calculate this T2 dash, it will become 553.8096 Kelvin. So in the answer we have to tell enthalpy difference in the of the air at the exit and inlet of compressor. So where the compressor exit is, here compressor exit would be the 2 dash. So delta H would be H2 dash minus H1 means Cp T2 dash minus T1. So Cp is 1.005 kilojoule per kg and T2 dash 553.8096 minus 310, and when we will calculate it will become 245.0287 kilojoule per kg. Thank you.